Thanks for inviting me to this. It's coming to events like this is a great privilege, particularly now I have left academia. I've defected to the commercial world and I'm working with NAG. This is an extension of a talk I gave at the University of Bath a couple of months ago when the head of research computing there said, "We want you to come down and upset everybody. Will you please give some kind of a talk that ruffles feathers and gets everybody talking?" So I wrote a talk called HPC Why No One Cares, which it turns out when you put that on Twitter and a lot of HPC people follow you, you get quite a kicking. So I took it a little bit to why so few people care. So, this was part of the talk that I gave at Bath, and I just wanted to sort of set the scene. I have been involved with HPC at almost every level at one point or another. I was a user of it when I was an academic at Sheffield. When I was at Manchester, I worked alongside people like Ian and Simon supporting HPC, along with Paul Richmond. So I told you this is my past around here. Along with Paul Richmond, I co-founded the Sheffield RSC Group, where we developed and supported HPC services for a very brief time, which is a story that we had over beer. I was head of the HPC Centre at the University of Leeds, and now I work with a company that provides commercial HPC services. Okay, so it's kind of dangerous to give a talk why nobody cares about HPC when your career depends so critically upon it. So why that title? Why the title Nobody Cares? Somebody gave a talk at JupyterCon called I Don't Like Notebooks, which I just thought was fantastic. And when you actually look at the talk that this guy delivered, and you see all the discussion that followed from it, you realise that this wasn't just a beating up on Jupyter Notebooks. This was something that the notebook community could take on board and say, how can we change? How can we respond to these criticisms? Are they valid criticisms? Is this something that we should ignore? Or other things that we can do to improve what we are? And so I'm trying to do the same with HPC. So this is a talk, this is based on a talk I've given a couple of times where I say one of the problems with HPC as we currently practice it is that it's geek topic. Okay? And what I mean by this is, I've been guilty of this by the way, when you are part of the University Research Computing Group and you've got a new HPC facility, you desperately want to tell everybody how many cores you've got, how much money you secured as a HPC manager, how many gigaflops it would have if you ran the LIMPAC benchmark, the bandwidth, your MPI latency. You love to talk about this stuff. So when you give these talks though, and like I say, I'm guilty of this, I'm not saying you are bad and I am perfect, quite the opposite, I'm guilty of this kind of thing as well. You then say to the audience, the modern audience, are there any questions? I gave this talk in the University of Sheffield Computer Science Machine Learning Master's course. And when I asked them any questions, somebody said, what's a core? I'm not making this up. What's a core? Other questions I've had over the years are, I tried your fancy HPC system. It runs my R script more slowly than my MacBook Pro. And then, now we all laugh. But the thing is, so I over the years I've played with people from who work in finance, and a huge amount of huge financial models are run on Excel. And if you say to them, why on earth do you use Excel? They sit and go, Mike, when you earn a salary of this big, and your boss says, I don't care what you do, as long as I can use it from Excel, you use Excel. You see, in the HPC community, we like this kind of thing. We like fancy cars that are super fast, the kind of thing that would be on Top Gear, that if you're not an expert driver, you will quickly crash and explode and so on. That's the kind of thing that we like as HPC nerds. Our users need something like this. They need something that can get from A to B, they can chuck a bunch of crap in the back and everything will be just fine. That's what they need. And for many years, the HPC community haven't been all that interested in serving these kinds of people. There was an interview of 114 researchers at Princeton University. It's a very good university, and they showed that 40% of them never use a HPC system. And these guys went on to say, these are some of the comments from the paper, despite enormous wait times, many scientists will just run their programs on desktops. Do people still think this is true today?
More so.
More so, okay. About a third of researchers don't use any form of parallelism in their research at all. And we all know that if you don't make use of parallelism, you're not taking advantage of any of the modern updates on modern processes. And currently, and I've seen this tons of times, many researchers fit their scientific models to only a subset of available parameters for faster program runs. They limit their science according to what they can run on their laptop in about a day. Okay? You could argue over it's about a day or a couple of days or whatever, but that's pretty much. And yet, Prabhu et al. Went on to say that across disciplines, an order of magnitude performance improvement was cited as a requirement for significant changes in research quality. And if you go to most people who are doing computational research and you say to them, that thing you do, I could do it 10 times faster, 10 times bigger, 10 times more accurate, you want that? They want that, just like I would want to. So, I actually would argue that more people need HPC than ever, but it's pretty hard to use. And so what I would argue is that we need to come up with a new geek top trumps. Instead of saying we've got the most processors or we've got the fanciest tech, we need to be able to say our HPC is the easiest to use in the world. This is the kind of thing that we should be aspiring to. Certainly within initiatives like the NA, computational intensive research. When I give talks like this, inevitably somebody will run up and say, in my research group or at my university, we've solved some of these problems. We've got this awesome tech. Great. Why hasn't everybody got it? That's the problem.